Calculated column is a column that you add to an existing table and use DAX to calculate the column's values. The calculation is done row by row, and this is what's called a row context. What's a row context? First, let's understand what we mean by context. Context is basically the data set that is being used at a given moment. So here in our sales data table, if we were to calculate the margin in this row, the context or data set would be referred to as the row context. But if we wanted to only see the margins for the locations in, let's say, London, then we're changing the context or our data set from just the specific row to instead a data set that's only based on London, and that's referred to as a filter context. So if we had this table in Excel, we would just add a filter and select London, and we would get our filter context. But to get the same result in Power BI, we will need to use measures in DAX. But first, let's learn how to create our calculated columns. We're going to create 4 calculations here in our sales data table. First, let's calculate our sales value. In the Table Tools tab, click on New Column, and a new column is added to our table. Here in the formula bar is where we will create our calculation. In Excel, you start off your calculation with the equal sign, but in DAX, you start off by giving your calculation a name. Let's call this sales value, and then the name is followed by an equal sign. We know that our sales value would be our quantity sold multiplied by our price per unit. So let's start typing quantity, and our table sales data with the column name quantity sold comes up. So let's select that. Just to note, when we're performing calculations in Excel, we reference a cell like A1 or a range like B1 to B10. But in DAX, we reference columns or tables, and column names are always in square brackets. Next, let's insert the multiplication sign, and let's start typing price, but the column that we require, price per unit, doesn't show up in our IntelliSense. This is because it's in a different table. It's here in our product list table. So we need a function like VLOOKUP to help us look up the prices in the related product list table. And in DAX, that function is called related. So let's remove price and let's type related, and the IntelliSense brings it up so we can select that. And automatically all the columns that we have on the one side of our relationship comes up. Remember, our calendar table and product list table were on the one side in the data model, and our sales data table was on the many side. So the related function fetches the value from another table based on the existing relationships in your model. It goes through a one-to-many relationship. It grabs the value from the one side of the relationship and brings it to the many side. So let's select product list price per unit and insert the close brackets and hit enter, and we get our sales value calculation. Now let's calculate our cost of sales. We'll follow the same process. In the Table Tools tab, click on New Column, and let's call this new column COS for cost of sales, and type the equals, and let's start typing quantity, and the IntelliSense brings up our sales data table with the quantity sold column, so let's select that, times, and let's type related, and the IntelliSense brings it up. Remember, we need to use related as our cost per unit is in a related table, so let's select product list cost per unit and insert the close brackets and hit enter, and we get our cost of sales. Next, let's calculate our margin. Insert a new column and let's call it margin equals, and let's type sales value, and our sales data table with the sales value column comes up, so let's select that and insert a minus and type COS, and we get our sales data table with the cost of sales column, so select that and hit enter. As both these columns are in the same table, we didn't need to use the related function. And lastly, let's add one more column and calculate our margin percentage, which is simply our margin divided by our sales value. For this calculation, we're going to use the divide function instead of the divide operator, as the divide function will return blanks in instances where our denominator is 0. Our numerator is our margin, so it's sales data margin, insert a comma, and our denominator is our sales value. And it's our sales data table with sales value as the column, so we can select that, insert a close bracket, and hit enter. And we have our margin percentages. Let's change our format to a percentage, and let's change our number of decimals to 0. So we now know the basics of creating DAX formulas when we use calculated columns. But now we can see that the values from a calculated column are created for each row as soon as the formula is entered. So this means that the values are stored in the memory data model. So when you start adding more and more calculated columns, this will not be ideal, as this will use up space and as a result slow down your query. This is where measures come in. Measures are similar to calculated columns, but they are created outside of a table and can be used in multiple tables and visualizations. So they do not belong to any specific table, as they're only calculated when you need them. Let me show you what I mean. Let's calculate our sales value as a measure. To create a new measure, in the Table Tools tab, click on New Measure. Notice that a new column was not added to our sales data table, but instead it was added as a field here in the data section of our sales data table. So we will create our measure here in the formula bar. Let's call this measure M sales value so that we can easily distinguish between our measure and calculated columns. You can also determine which is a measure and calculated column by the icons. So a calculated column is this column with a sigma sign, and a measure is a calculator icon. But for the purposes of this video, I'm going to add the letter M for measure. Just a quick tip. If you need to zoom in and out of your measure, you can click on the formula bar and hold down the Control key and scroll up or down with your mouse to zoom in or out. Let's insert the equal sign and start typing quantity sold. And we would expect the IntelliSense to come up with our table and column names, but it doesn't. Instead, quantity is grayed out. This is because we're trying to use a row context in a measure. Let's go back to our sales value calculation that we created using a calculated column. The syntax for calculated columns is our column name equals, and then it's our table name followed by the column name. So this is the syntax for a row filter, which can only be used in a calculated column. So then what do we use in a measure? Because we know that we need these exact column names in these tables to calculate our sales value. When we're creating a measure where the calculations are based on existing columns in a table, we need our calculation to move row by row in our table. So it needs to calculate for each row quantity sold multiplied by the price column from our product list table. So we still need this section of our formula in our measure. So let's copy this section of code and go back to our M sales value measure, and let's paste it here in our formula bar. Notice our column names are still grayed out, as Power BI knows that we're creating a measure, and this syntax here is for a row context. And a row context is not possible in a measure. It's only possible in a calculated column. See, the BI developers at Microsoft had a meeting to discuss the best way possible to ensure that our reports and dashboards were created in the most optimized way possible, where our storage and memory would be used as little as possible. And that's where measures come in. Measures are dynamic formulas where the results change depending on the context that we used. So in that BI developer meeting, they decided that instead of storing the values from each row's calculations in our table, a better way would be to not have the results of our calculation immediately produced anywhere. They decided that when we give our formula context, then only will the results be produced. So a calculated column will calculate each row's value and you will immediately see the results in your table. But a measure will calculate the sales value for each row, which is quantity sold times price, and once Power BI gets each row's values, it sums it up, if that's what you tell it to do. You could also tell it to calculate the average or min or max or more, and when you tell Power BI, you want to see the sales value for, let's say, each location or for a specific time frame, then only will you see the results of that calculation. So essentially, you'll only see the results of your measure when you use filters or slices. And this is what the developers decided to call filter context. When we give our measure context, then only will we see the results. And of course, this solves the problem of using up space in our reports. So let's get back to our sales value measure. We're calculating our quantity sold by our price. And now we need to determine what do we want our filters to be based on. Well, if we had to select a filter based on location, then we want the summed up value for, let's say, London. And the same logic would apply if we wanted our filter based on a specific time frame. We would want the summed up value for a specific month or year, for example. So let's type sum here before our formula, and then IntelliSense brings it up. But our column names are still grayed out. Let's look at what sum requires. It shows that it only accepts a column reference as an argument. So it only accepts column names and not tables or expressions. So this is where iterating functions come in. These are the functions with the X at the end of it. The X stands for expression. So let's type SUMX here. And the first argument that it requires is a table. This is the table containing the rows for which the expression will be evaluated. So let's type sales data for our table and insert a comma. And this is the expression that will be evaluated for each row in our sales data table. And we can press enter, and our error has disappeared. And here on the right is where we will see our sales value measure. But as mentioned before, it will not physically show up in our sales data table. So let's see how it will show up. Let's go to our report canvas and let's expand our visualizations pane, and here in the Build Visual tab, let's select the table visual and it gets added to our report canvas. To populate this visual, we will need to add fields from here in our fields pane. When we expand the fields pane, we can see our tables from our data model. Let's expand sales data and let's drag and drop sales value to columns. Remember, sales value was our calculated column. And now let's add our sales value measure. That's the measure that starts with the letter M. So we get these two columns in our table that we can compare. Both values are the same, so that's a great start. Now let's add a column that shows our sales value by location. Location is here in our sales data table. So let's drag and drop that here. And we've changed our context from showing us only the summed up value of our measure to now showing us our measure in the context of location. So this is how filter context works. We did not see the results of our measure until we visualized it here in our report canvas. So measures can only be seen when we give them context. So just to recap, a calculated column is a column that you add to an existing table and then create a DAX formula that calculates the column's values. The values in a calculated column are calculated for each row as soon as the formula is entered. These values are then stored in the memory of your data model. Calculated columns use the row context, meaning the calculation is based on the specific row where the calculation is being performed. As calculated columns belong to a specific table, you need to specify the table name, then the column name in square brackets. If the column that you need to use is in a different table, related can be used as your VLOOKUP. Then, as normal, specify the table name and column name in square brackets. A measure is a dynamic calculation using DAX, and it does not exist in a table. The values for a measure are not immediately output anywhere. The values will only be determined when we give the measure context. As measure values are calculated on the fly, they are not stored in the memory of your data model. Measures use filter context, as we mentioned in point 8. The values will only be determined when we give the measure context. Let's create the rest of our measures. Click on New Measure. Notice that we're creating this in our report canvas and not in the data view. That's because you can create your measure or add a new column in any of these 3 view types. So you can even add a new measure here in your model view. The column or measure will be added to the table that you have selected. But let's go back to our report view, as I prefer this view for now. You can use the data view or the model view if you prefer. Let's call this new measure MCOS for cost of sales, and the M is to show us this is a measure, and insert the equal sign. We could just copy the formula from our cost of sales calculated column, but let's rather write this from scratch. But before we get to that, 80% of my viewers are still not subscribed. If you're getting value from this video, I would really appreciate it if you could please hit the subscribe button, as this will really help me hit my 2023 goal of attaining 50,000 subscribers. I know that we can do it. Now let's get back to our video. Let's use the SUMX function as our iterating function. And we know that if we're using columns from a table to calculate our measure, we need to use iterating functions. And iterating functions also allow us to use expressions in our calculation. The first argument is the table that our function will iterate over. So let's type sales data and insert a comma. Then for our expression, let's type quantity, and the IntelliSense brings up the sales data table with the quantity sold column. So let's select that and insert the multiplication sign, and let's type related, and let's select the product list table with the cost per unit column and insert the close bracket and hit enter. And we can see our measure here in the calendar table. We didn't select a home table when we created this new measure, so the measure will default to the first table. We can change that here in Measure Tools. Here under Home Table, let's select Sales Data, and our measure moves here to our Sales Data table. Next, let's select our Sales Data table here in the Fields pane and select New Measure. And let's call this measure M Margin. So this measure's home table will be the Sales Data table, and it won't default to the first table. Equals, here we're going to use our sales value measure minus our cost of sales measure. And notice we didn't have to reference any tables. So when you're using measures in your formula, there is no need to specify table names. The reason for this is, as we know, measures don't belong to any tables, and the results are calculated on the fly when we need them. And let's hit enter, and we have our margin here in our sales data column. Let's compare our margin measure to the one in our calculated column. Let's remove the sales value fields here by Xing them out. And let's drag our margin and M margin, and they're the same. Next, let's calculate our margin percentage. We'll follow the same steps. Ensure that your sales data table is selected. Click on New Measure, and let's call this new measure M margin percentage equals, and we're going to use the divide function, just like we did in our calculated column. Our numerator is our M margin measure. Then insert a comma, and our denominator is our M sales value measure. And hit enter, and we have our margin percentage measure here in our sales data table. Let's compare it to the margin that we calculated in our calculated column. Our calculated column margin is way off from our measure. That's because it's being summarized by default. We can switch this off by clicking on this drop-down arrow here and selecting Don't Summarize. And we can now see the distinct values for this column. So to recap, to calculate a measure using columns from a table in our data model, we need to use iterating functions. Iterating functions allows us to use expressions in our formula, and these are the functions with the x. Measures do not belong to a specific table, so when you're using a measure in your formula, you don't need to reference a table. Okay, so now that we understand the difference between a measure, calculated column, filter context, and row context, hopefully this sets the foundation for building your measures.